As with sine and cosine, there's a similar strategy system for tangent and secant. So if n, which is the power of secant, is even, you split off a secant squared and rewrite the remaining power, even power of secant in terms of tangent, and then use u equals tangent. If m is odd, then you split off secant tangent and rewrite the remaining even power of tangent in terms of secant, and then use u equals secant. And then if m is even and n is odd, then you rewrite the even power of tangent in terms of secant to produce a polynomial in secant, and then apply a reduction formula for each term, to each term. Reduction formula for to each term, sorry. The reduction formulas will be actually in a couple pages, so you'll be able to see those when we get there. All right, so let's look at this particular problem. So you can see that m, which is our power of tangent, is 5, and n, which is our power of secant, is 4. So you might be thinking, well, m is odd, so I could use this method, or I could use n is even, so I could use this method. The answer is you could actually use either one. So use either number 1 or number 2. Either one will work. It's fine. All right, so I think I will split off a secant squared. Why not? I'll use number 1. So if I rewrite this, I'd rewrite it as the integral of tangent to the 5th of x. I'm going to split a secant squared off. So it's secant squared of x times, and then the remaining secant squared of x dx. All right. Now, I rewrite the remaining even power of secant in terms of tangent. Okay, so that's this one right here, secant squared. So secant squared, because of the Pythagorean identity, is equal to tangent squared plus 1. So this will be equal to the integral of tangent to the 5th of x, and then it'll be 1 plus, or excuse me, tangent squared x plus 1, or 1 plus tangent squared x, either way. And then secant squared of x dx. And that's the Pythagorean identity. All right, so then that would be the integral of, I'm going to rewrite this. Well, you know what? Let's just do it this way. U is secant squared. So if I let u be, oh no, I decided to use method 1, sorry. U is tangent. I forgot which method I was using. All right, so u is tangent of x. Then du is secant squared. There we go. Which will be this piece. So u is tangent right here and right here. So that means that I have u to the 5th and u squared plus 1, and then times du. All right, so that would be the integral of u to the 7th plus u to the 5th. Love those basic algebra techniques of just distributing, right? No need to do integration by parts or anything else funny. Du, which would be 1/8 u to the 8th plus 1/6 u to the 6th plus c. Oh, of course this is tangent, so I don't need to put it in parentheses like that. I can just say tangent to the 8th of x plus 1/6 tangent to the 6th of x plus c. And again, we chose to use number 1. Not for any good reason. You could have used either one of them, wouldn't have made a difference. It was fine either way. Now you can feel it coming. If it works for tangent and secant, then won't there be a similar method for cosecant and cotangent? And the answer is, of course there will be. Why wouldn't there be?